Hi there. So this is our first set of kind of review days here. So we're going to start with quadratic functions. This was our first unit of the year. Um, so our first topic here is transformations of quadratic functions, which we really can think of as vertex form. So we're going to go through some notes together. I'm going to leave some examples for you to do. And then if you're interested in checking out your skills some more, I've set up a Desmos activity here that you can check out as well. So vertex form, remember, looks like y equals a times x minus h squared plus k. So really we've got these three big components here, a, h, and k. So let's talk about those. So h is the x coordinate of the vertex. And so remember, we're going to use the opposite sign there because there's a negative sign built into vertex form. So then k, remember, is the y coordinate of the vertex. And that one we use the exact same sign there. So k is the y coordinate of the vertex, and then we use the, whoops, I meant to say same sign. Boop-a-boo. So h and k, we've used those in other transformations all year long. Remember, they are talking about the vertex here in this case. And then that a value out in front tells you about the shape of the parabola. Let me highlight that briefly. So a tells us about the shape of the parabola. So if a is positive, then our parabola opens upward, right? It'll look like a U shape here. If a is negative, then our parabola opens downward. And so in these cases, right, we'll have either our vertex be a minimum if it's at the bottom of the graph or a maximum if it's at the top. Now, the size of a, or the absolute value of a, also tells us about the kind of the shape of the graph, whether it's going to be narrow or wide. So if the absolute value of a is greater than 1, so whether it's something like 2 or -2 or 10 or -10, if it's an absolute value bigger than 1, then it will be narrower or skinnier than y equals x squared, which remember is our parent function. And so we can think of it as if our a value is bigger, whether it's more negative or more positive, we're kind of stretching it upwards. Whereas if our absolute value of a is less than 1, so some sort of decimal value between -1 and 1, then our graph will be wider than y equals x squared. We're kind of flattening it out and spreading it out. So we're going to be practicing graphing here, which is going to help you with your graphing project. And so a good pro tip here, just as a reminder about graphing these, is making a table, right? We know that making a table is always a great strategy for graphing. So if we want to make a table here, we can find the vertex. Let me make that a little bit clearer. We can find the vertex first, right? We know vertex form. We can find the vertex first, then pick x values around it. So that's what we're going to practice here briefly. We're just going to talk about, we're going to practice finding the vertex, and we're going to practice graphing, and we're going to practice identifying those features. So just a couple of examples right here. It says identify the vertex of each of the following quadratic functions. So remember, our vertex is hk. So our h value is the opposite of the value that's inside those parentheses, and our k value is the same as that value outside, right, being added or subtracted. So in this case, our vertex is +3, +1, 3, 1. So let's check out these other two. So our vertex here, we've got our y value and we've got our x value. right? If it's going to be a plus 3 inside, that's the same as x minus negative 3. So our vertex is going to be negative 3, 9. And then this last example right over here, our vertex will be positive 1, negative 11. So let's practice using this vertex to make a graph and then identify some of those features from way back when. So consider this equation y equals negative 2, or excuse me, x minus 2 squared minus 7. So again, we need to find our x coordinate and our y coordinate of our vertex. So our vertex here is 2, 7. So I'm going to start by making a table, and I'm going to put my vertex right here in the center of my table because I know that a parabola, a quadratic function, is symmetric around the vertex. And then I'm going to pick some other x values around that. So not negative 1, hold on. 1, 3, 0, 4, and then maybe just in case I need it, I will go back to negative 1 and 5. So to find those y values, just like we've done all year long and since 8th grade, right, we plug in those x values. So 1 minus 2 squared minus 7. I plug in that x value 1, and that's going to give me negative 1 squared minus 7. That would be 1 minus 7, or 6. So that will be my y value there. And then remember, since parabolas are symmetric, I can just pick those other y values that are on the other side of the vertex there. All right, now I'm going to do the same thing with an x value of 0. So 0 minus 2 squared minus 7, that's negative 2 squared minus 7. Negative 2 squared is 4. So this will give us, oops, you know what I did wrong? Hope you caught that. My y coordinate is not 7, it's negative 7. So this is negative 7 for my vertex there. And then my actual math here, let's see, negative 1 squared minus 7 will be negative 6. My apologies there. You know, these things happen. And then our other y coordinate here will be negative 3 and negative 3. All right, so if you were sitting there wondering, when is she going to go back and fix that? Mistakes happen, you know that. Um, we're okay. So thanks for being patient with me. And then let's do negative 1, minus 2 squared. Just finish this one up just in case, minus 7. So this will be 9 minus 7, or 2. So I'm going to plot these points here. So I've got 2, negative 7, and then 1, negative 6, and 3, negative 6. And then 0, negative 3, and 4, negative 3, and negative 1, 2, and 5, 2. So remember, to graph a parabola, it's best to have 5 points at minimum, just to get a better picture of it. But there we go. So we've got our parabola graph there. Now we already know our vertex. It is 2, negative 7. It only took me 2 tries, but I did it. And then since our vertex is right here at the bottom of our graph, this will be a minimum. Our axis of symmetry, remember, goes right down the center of the parabola. It is a vertical line, and it's at the x value 2, so we're going to write x equals 2. Our y-intercept, you know that that's where the graph crosses the y-axis. So in this case, it is 0, negative 3. Remember, if I didn't have it graphically, or I didn't have it in my table, I can always just plug in x equals 0, and I'll always get my y-intercept there. The x-intercept is where our graph crosses the x-axis. And when I look at this, I know it's not exactly at 5, 0 or negative 1, 0. So I'm going to have to estimate just a little bit since I'm doing this graphically, and that's okay. So I'm going to estimate this as negative 0.750, right? It's not quite at -1, and then maybe 4.750. It's not quite at 50. And so domain and range, let's talk about the domain and range of our parabolas here. So remember, this one is not only going up forever, but it's also going to the left and to the right forever, which means that it covers every single x value from -infinity to +infinity, aka all real numbers. Now our range, since it goes up forever, it doesn't go down forever though, it's got a minimum value at -7, and then it goes up and up and up forever. So I'm going to say that my range is y is greater than or equal to -7. So again, right now we're just kind of practicing how do I use vertex form, how do I use it to find the vertex, and then what are the features? We're just kind of reviewing what all those features are. So we're going to do another example together, and then I'm going to let you finish examples 3 and 4 on your own. So example 2 here, we've got negative x plus 4 squared plus 1. Now remember that a value, in this case, it is a -1. So our graph is going to open downwards, but it's not actually going to affect our vertex at all. So let's take a look at that vertex. Inside the parentheses, we've got +4. Outside, we've got +1. So our vertex is going to be -4, +1. Pretty sure I did that right this time, right? We're using the opposite sign as what's inside the parentheses and the same sign as what's outside. I'm just going to jot that down, -4, 1. And then I'm going to make my table. I'm actually going to scoot my table over just a hair. And I'm going to put my vertex right in the middle, -4, 1. And then I'm going to put some other x values nearby. And -3, -2, -1. And I'm going to put 0 there just because I'm going to look for my y-intercept eventually. So I might as well figure it out along the way. All right, so I'm going to plug in some x values. Negative, don't forget that negative out in front like I almost did. -3 plus 4 squared plus 1. Oops. So -3 plus 4, that will be 1 squared. So this will be -1 plus 1, aka 0. And I can remember I can get 2 points for the price of 1 because it is symmetric. And then I'm just going to keep going here. So -2 plus 4, that's 2. -2 squared is -4 plus 1, which is -3, and I get 2 points for the price of 1. And I'll just keep going, -1 plus 4 squared. This will be 3 squared. So -9 plus 1 gives me -8. And then it looks like, I'm just going to do this work up here, that my y-intercept might be off my graph, but that's okay. If I still need to identify it, then I still need to identify it, and that's okay. It'll be -16 plus 1, aka -15. So I'm just going to jot down that y-intercept while I've got it fresh in my mind. And I'm going to graph these points here. So -4, 1, -5, 0, and -3, 0, -6, -3, and -2, -3, and then -7, -8, and -1, -8. So this confirms what we mentioned about the a value earlier. It should open downward, right? And our vertex is at the very top, making it a maximum. Again, our axis of symmetry goes right down the middle of our parabola. It goes right through the vertex. Remember, it's the same x value as the vertex. So x is equal to -4. This time our x-intercepts are spot on, right? We can see them pretty easily here. It's where y is equal to 0. So I'm just going to jot down those points. We've got -5, 0, and -3, 0. Again, this is a parabola. The domain is going to be all real numbers. Remember, that's every single x value, positive, negative, decimal, whole number from -infinity to positive infinity. And then our range, this time we already noted that our vertex was a maximum. We've got a highest value of 1, and it goes downwards forever. So our range is y is less than or equal to 1. So this will take just a little bit of remembering here. And again, I really encourage you to check out that Desmos activity as well, just so that you can double check those skills and stay engaged with the content. So try example 3, example 4 on your own. Oh, that should say example 4. Whoops. And the answer key will be in OneNote. And again, I really appreciate you checking in. I miss you guys. And I will hopefully see you at our Zoom conferences. And I will talk to you later.